Hey guys, Alex Fast here, back for another Baseball Savant tutorial. First and foremost, thanks for all the great feedback in the first video. Really made my day to see how much you guys were enjoying the website and the tutorials. I wanted to let you guys know we're going to be posting these videos every Monday and Friday for the foreseeable future. We're also going to have some pretty awesome guests coming on in the coming weeks to help us break down even more in-depth sections of the site. Don't forget to reach out to us on Twitter at SavantTips or AlexFast8 with any questions you may have, any video requests you guys may have as well. In our first video, we started to look at the search function. We covered a majority of the fields, including pitch type. We did attack zones, quality of contact, batter handedness, game date, position, outfield alignment, all of it. I'm going to be sure to leave a link in the comments to the first video in case you missed it. Today, we're going to look at the remaining fields in the search function, including metric range, min of total pitches, sort order, group by, and more. So why don't we go ahead and get started with one of the more lofty fields in metric range. So if you click on the metric range field, you're going to notice that there are a lot of things which you can sort by. To help introduce you to the metric range field, however, let's start with a more rudimentary selection from the field in exit velocity. Now you're going to notice that once exit velocity is selected, two new fields appear to the right, a greater than or equal to sign, a less than or equal to sign, and even further to the right, a search another metric field. So we're going to stick with just exit velocity for now. This is going to give me the ability to see every ball in play that had a certain max and min exit velocity. So for example, let's say I wanted to see every ball in play that had an exit velocity between 80 and 100. So I'd click on the greater than or equal to sign, and I could scroll down to 80 here. And if you don't want to scroll, you can actually also just type the number and it'll take you to it. So to get to the less than or equal to 100, I can just type in 100, takes me there, just press enter. Now, if I don't put in any other fields and I just hit search, what do I get? Well, okay, so because pitcher was selected in player type, which is a field that we reviewed in our first video, I am looking now at how many pitches resulted in a ball in play that had an exit velocity between 80 and 100 miles an hour, 800 miles an hour. Wow, couldn't even see it. So Mike Leake threw 385 pitches that resulted in an exit velocity between 80 and 100. So if I wanted to see how many batters recorded balls in play with that same exit velocity filter, we'd simply change from pitchers to batters in player type. But I want to get more specific, though, and utilize some of the fields we learned about in the previous video. So let's say I wanted to see how many home runs were hit with an exit velocity between 110 and 125 miles an hour. And if you want, you can pause the video, try and figure it out for yourself here. But what I'm going to do is go to PA result, select home run, and then we made sure that batter is selected and input the range I want, and I'm going to press search. So we said between 110, I'm just typing in 110, and then going down to pressing 125, and we're going to go ahead and select search. And there it is, Rookie of the Year, Pete Alonso, tied with 19 home runs, tied with Gary Sanchez, 19 home runs. That was home runs with an exit velocity between 110 and 125. And if I wanted to see every home run hit over 110 miles an hour, by the way, I could also just leave this blank, right? If I wanted to see every single one hit over 110, I could just put in 110, select search, and then it would give me everything. So you don't need to necessarily fill in the less than or equal to field, although it's going to give you the same results for this particular instance. Let's say I wanted to search by more than just exit velocity too. Let's say I wanted to look at every home run that had an exit velocity between 90 and 110 miles an hour with a launch angle of 20 to 25 degrees, okay? So what I would do is click search another metric, and a new metric type field is introduced. So I'm going to do 90 to 110 here. And in metric type, we also want to search by launch angle, and we said between 20 and 25 degrees. Now, you may have noticed that there are some negative degrees here. We're going to get into that a little bit later. For now, though, we're just going to hit search. And here are my results. So it looks like Yuli Gurriel and Trey Mancini both had 13 home runs with an exit velocity between 90 and 110 miles an hour and a launch angle between 20 and 25. Don't forget, one of the best things about Baseball Savant is you can see video of every single one of these. Just click on the field here and then click here and then bam. You have the video, one of the videos of Yuli Gurriel's home runs that was hit between 90 and 110 miles per hour with a 20 to 25 degree exit velocity. Just absolutely love to see that. Also, remember to bring in other fields that we reviewed before, add barrels or line drives or attack zones or game day zones or count. The possibilities here are truly endless. I want to clear this search here for a second, and then I want to return back to metric range, okay? So if we go down to metric range, we see that there are a heck of a lot of options here, and because doing a search for each would make this video hours long, I'm just going to fill you in on what each of them means, and then if you have any questions, you can certainly reach out to us on Twitter, at AlexFast8, at Savant Tips. We already did exit velocity, pitch velocity as it sounds. You can search by the velocity of the pitch thrown. I would use this if I wanted to see who threw the most fastballs over 100 miles an hour or which batter saw the most sliders above 90 miles an hour. Launch angle, we just went over kind of briefly. Now, I brought up that there were negative values here, and as you see, we can go all the way down to negative 90. If a ball is hit at like negative 50 degrees, that's going to be right down in the dirt, whereas something with like a 20 or 30, 35 degree launch angle is going to be up in the air. Closer to zero is going to be more of a line drive. Launch direction. In which direction was the ball hit? Okay, so 0 degrees is pretty much straight away to dead center. Imagine there's a line between home plate and to dead center, 0 degrees right to dead center. So that means anything below 0 degrees, so negative, is going to be left field, and anything above 0 degrees is going to be to right field. Now, launch direction pull opposite is a little bit tricky, so I'm going to see if I can break this down. This is going to normalize the launch direction to one side of the field, regardless of pitcher or batter handedness. So it essentially allows you to query both righties and lefties in one search. So for example, if I searched launch direction for batters between negative 80 and 30 degrees, I'm going to get hits to the third base side, right? Because it's below 0. So I'm going to get hits to the third base side for both righties and lefties. If I search that same query, okay, but I select launch direction pull opposite as opposed to launch direction, I'm going to get hits to right field, I'm going to get hits to the third base side for righties, but now I'm going to get hits to the first base side for lefties because it's going to normalize in which direction they are hitting from, okay? Once again, any confusion, feel free to reach out. Distance projected, this one is much more straightforward than launch direction pull opposite, okay? It's fairly straightforward. This is just the projected distance of the hit. So, for example, you can search for every hit that went between 250 and 300 feet. Release extension is going to be how many feet of extension a pitcher got upon throwing a pitch. Release spin rate is going to measure the spin rate of a pitch at release. Lineup position allows you to run a query based on where a batter was hitting in the lineup. So, for example, if I wanted to see who hit the most home runs while batting first in the order, I could do that. But now I want you to remember that doesn't mean leading off, right? So, for example, if George Springer is hitting third that inning, even though he's bat first at the top of the game, he's still hitting first in the order. So once again, this doesn't necessarily return you every leadoff home run. Hopefully that's clear. Effective speed, this is the same thing as perceived velocity, and the verbiage may actually very well be changed by the time I'm done with this recording. This might actually read perceived velocity later on. This is the derived speed based on the extension of the pitcher's release. Okay, so the best example I like to give of this is Tyler Glasnow. Tyler Glasnow gets a lot of extension, right? Because he's such a long and lanky dude. So his 95 plus mile an hour, 97, 99 mile an hour fastballs look even faster to a batter because he gets so much extension. He's reaching out so close to home plate that by the time he releases that fastball, it looks like it's coming even faster than the miles per hour reading records it. So effective speed or perceived velocity gives us a good idea as to how quick that actually looks. Plate speed, this is going to be the speed of the pitch as it crosses the plate. Release position X. Okay, so this is going to be a little bit tricky. So to accurately convey this, it's going to be tricky to do. Okay, I'm going to do my best here. Release position X and Z, Y I believe is going to be removed. So release position X and Z are similar in that they are both the release point of a pitch measured in feet from the catcher's perspective, okay? Because we're measuring in 3D space, though, we can't just say one number. If we said Clayton Kershaw's release position was 6 feet, that doesn't take into account the horizontal or vertical. It might not take into account. So we have 3 different points to help get more specific where it is in a 3D space. Now, I believe one of the points, like I said, the release position Y is going to be removed. So we're going to focus on release position X and Z. Okay, so think of X like X-axis, so horizontal. So actually, why don't we do this? Why don't we run a query here? We're going to look at Mike Clevenger. I want to see every pitch Mike Clevenger threw with a release point X between 0 and 5 feet. Okay, no results for the search. Very interesting, right? Now, let's see actually what happens. I'm going to explain why there are no results for that later on. Let's see what happens if we flip this, right, and make it between -5 feet and -1 feet. And there we go, right? Okay. Now we have 94.3% of the pitches that Mike Clevenger threw had a release point X between -5 feet and -1 feet. Now, I'm going to get into graphs a little bit more in depth in our next video, but for now, we're going to click on graphs and we're going to do release point chart just so we can make a little bit more sense of this, okay? If Mike Clevenger is standing right here, right, and he's a righty, his pitches are not going to come from over here. Think about his throwing motion. He's a righty. We're at the plate right now. His arm's going to come here to throw because he's a righty, not over here, right? Hence the negative numbers. You'll also notice the y-axis here. Because we're in 3D space, we're going to treat this as the z-axis. So you would use release point Z to see how many pitches a pitcher threw over 6 feet or over 7 feet high. Okay, so hopefully that's a little bit clear. So if we wanted to search release point X for a lefty, if we wanted to search this for Clayton Kershaw, then you would search for anything between +1 feet or 5 feet, as opposed to what we just did there for Mike Clevenger. So the same axis alignment is actually going to be true for plate X and plate Z, right? So this is where the ball was horizontally and vertically when it crossed the plate, horizontally being plate X and vertically being plate Z. Relative plate X and plate Z are also, I believe, being removed. So, okay, expected batting average based on launch, speed, and angle. So before I dive into these next 4, let me give you a quick rundown of what they mean. So expected batting average, or XBA, this is a metric that measures the likelihood that a batted ball is going to become a hit. So each batted ball is assigned an expected batting average based on how often comparable balls, in terms of launch angle and exit velocity and sometimes even sprint speed, have become hits since StatCast was implemented in 2015. So for example, with expected batting average based on launch angle and exit velocity, we can search every out that had an expected batting average between 800 and 950, right? So a guy has a great hit with a great launch angle and a great exit velocity. It should theoretically be a hit a majority of the time, but it was recorded an out. We can search for that. We can also run these queries for expected slugging, which is the same thing as expected batting average, but with slugging, expected ISO and expected xwOBA, right? So expected slugging being what was the likely slugging based off of exit velocity and launch angle, what was the likely ISO based off of exit velocity and launch angle, and same with xwOBA, right? What was the expected xwOBA or weighted on base average, right? Home score is how many runs does the home team have. Away score is how many runs does the away team have. And then home score difference, let's say the home team has 2 runs, the away team has 4. The home score difference would be -2. The inverse being true as well. Home team is up by 2 runs, it's +2. Bat score score. Okay, this is the score of the team batting. I could run a query looking at every time the team that's batting has 2 or 3 runs. Field score is the opposite. What is the score of the team fielding? And bat score difference, score of the team batting minus the score of the team fielding. Home win expectancy. So you can search by home win expectancy, which is the percentage chance a particular team is going to win based on score, inning, outs, runners on base, etc. Bat win expectancy, same thing, but just for the team up to bat. Pitch number this game is another example of a field that is being cut out. And pitcher batter times through the order, also kind of self-explanatory. You can search every time a pitcher is second time through the order, first, third time through the order, same thing with a batter. Wow, that's a lot. It's a lot. It's a lot. I'm so serious. Please reach out to us on Twitter if you have any questions. It took me a really long time to understand, just what release point X and release point Z were. So please reach out. We are happy to answer questions for you for sure. Okay, so with metric range finally all out of the way, we can go ahead and take a look at... Actually, I'm going to go ahead and clear this real quick, get a nice clean slate here. We're going to move on to inning, which is a lot more self-explanatory than metric range. You can search by any inning. I actually wanted to give you guys a quick test too. Knowing what we know now from tutorial 1 and this tutorial so far, it's not possible to pull up every single walk-off home run in 2019. Okay, so if you want to try and figure it out for yourself, go ahead and hit pause now. I'm going to go ahead and show you how to do it. Okay, so obviously walk-offs are going to be in the 9th or in extra innings, right? So the away team is not going to be able to hit a walk-off home run, so we want to set this to home. Now, we go to situation here, and we're going to select go-ahead run at the plate. And we're also going to select go ahead run on base, because if it's, it's a tie game and there's a man on second and the guy at the plate hits a home run, the go ahead run is theoretically on base already. So we're going to hit that. And then we also want to see plate appearances, home runs. And just like that, we hit search. And we go down here. And once again, because I cleared, I only looked at pitchers, which is great because, hey, now we can see which pitcher gave up the most walk-off home runs. Kind of shocking to see that Josh Hader gave up 2. Shane Green gave up the most, tied with Givens and Doolittle. Let's move on to batter. Be a bit more positive here and see who recorded a majority of those. So Trey Turner hit 2. Trevor Story 2. Will Smith also had 2. Carlos Santana and Harold Ramirez also had 2. So that's kind of cool to see. Okay, that's enough about Harold Ramirez. Actually, I want to take a look at minimum number of total pitches. This is one of the many ways that you can filter the searches that you're doing. For example, why don't we go back actually to one of the very first searches that we did in our first video, which was percentage of fastballs thrown. So we selected 4-seamers. We're going to keep pitcher there. Now, if I recall correctly, I believe it was Lance Lynn. Yes, it was. Now, what I want to do, though, is remember there are a few ways to get... sort by pitch percentage, right? So one quick way is to just click on it and bam, we see that Roman Quinn threw 64 pitches, 100% of which were 4-seamers. He's a position player. We want to get him out of that search. We want to filter out of there. So let's say we go to minimum number of total pitches and we include 500 pitches as the minimum. And we go back to sorting by pitch percentage here. And just like that, we've gotten rid of everyone who's thrown fewer than 500 4-seamers. Colin Poche, or I think it's Colin Poche, it might be Colin Poche, so I apologize there, threw 88.4% of his pitches were 4-seam fastballs. That's a heck of a lot. Let's stay with this example, though, and let's actually move on to minimum number of plate appearances. So I'm going to set this minimum of total pitches back to 0, and we're going to switch from pitcher to batter. Now, if I recall correctly, it was Jonathan Villar who saw the most 4-seamers overall last year, and then I think it was Brian Dozier who saw the highest percentage or something like that. We're gonna run this query and figure it out. It wasn't Brian Dozier, it was Adam Eaton. Either way, we're gonna add the minimum amount of plate appearances in a second. If we do the sort by one more time, we can see David Hess. I guess he's a position player, or excuse me, he's a pitcher who came up to hit. He saw 11 4-seamers. We're going to change the minimum plate appearances to 100, and that should take care of any relievers or starting pitchers that appeared and saw a certain amount of 4-seamers. So just another great filter that you can use. So once again, we got our results, And we see, oh, there it was. We see that the minimum was actually Andrelton Simmons. Oh, that's interesting. He saw the fewest four-seamers last year. That's a great way to like figure out, that's a great way to do analysis, right? I could do a whole side project about what kind of pitches Andrelton Simmons sees, but that's kind of interesting. I didn't know that about Andrelton Simmons. Minimum number of results. This is a similar filter. I'm going to go ahead and clear this out real quick. Minimum number of results. If you wanted to see like which pitcher had the most strikeouts on a four-seamer, but you wanted to set the minimum at 100 Ks, then you would go here, set to 100. We said four-seamer, and the result was strikeouts. So this will be the pitcher that had the most strikeouts on a four-seamer with a minimum of 100. Probably shouldn't be that many, yeah. So there were 12 guys, which is pretty cool. The fact that Josh Hader is there is also pretty cool to see. But yeah, and remember, you can use this filter for anything, right? You can use this filter to search singles, doubles, triples, walks, whatever you'd prefer. The kind of world is your oyster here. Let's go on and move to group by, though. Go ahead and clear this real quick. Start off with a clean slate. So in the group by fields, there's a lot to deal with. This is very, very important. We have player name, player and game date, player and year, player and event, team and game date, venue, league, and year. So I'm going to use one search example and then see how all these different fields or kind of apply. So let's take a look at home run leaders over the past 3 years. Okay, and why don't we actually just add in a filter that we just introduced, which is minimum number of results, and that's 50. So what we're going to be looking at here is the home run leaders for the past 3 years and make our list just show batters that have hit at least 50 home runs in that time. As you can see, we started with player name, so we've grouped everyone by player name. We have JD Martinez, Nelson Cruz, Mike Trout, etc. Keep in mind, group by is different than sort by, which we're going to get to in a bit. For now, let's move to the next field in group by, which is player and game date. So when we change that field and hit search, okay, we get an error. So, all right. Why is that? As of right now, we're telling the query to set a minimum of 50 home runs. So the query thinks, okay, I need to only show instances in which a player hit 50 home runs in a game, because we're searching by player and game date, right? And obviously that's never going to be the case. No one's going to hit 50 home runs in a game. So if we remove that, we remove the 50 home run minimum, then we're going to get all of our results. And there we have them. Now, if you're curious as to, which date this game happened on, when did Kyle Seager hit 3 home runs, you just click on his field. You see it happened on August 13th, 2019. And of course, you can select a video on every single one of those. Let's move on to the next field, which is player and year. We now have a list of every player's home run total in the past 3 years sorted by that home run total. Okay. Now, you may notice, however, that it doesn't say home runs, it says pitches. Yes, obviously, because not obviously, I'm not trying to be condescending here. 59 pitches resulted in a home run. If we went to change included stats and we selected home runs, then we would get a field that said home runs 59, but it would be the exact same thing. There's no difference there. Keep in mind also, if we re-added our minimum results filter of 50, we would only get 3 results: Stanton, Alonso, and Judge, right? Because we're not grouping by total home runs over 3 years. We're grouping by player and year. If we change to player and event, something important happens. That sort by changed, right? Now all the fields, it says player and event sort, and all the fields that appear here mimic those of metric range, which we just went over. So I'm going to spare you going through all of them again. So when we're searching by player and event, in this instance, our event is a home run. And we're going to be sorting by the exit velocity for all of those home runs, okay? So let's run that query real quick. Now, I promise you, I didn't add like a just show Yankees filter. They just really like to hit the ball hard. We got Stanton, Judge, Sanchez, a little bit of Alonso and Aristides Aquino in there. Now, obviously, there's a lot of home runs here, so to scroll to the very bottom would take quite a bit, right? This is every single home run in the past 3 years sorted by exit velocity. That's going to take a while. If you wanted to see who had the lowest exit velocity home run in the past 3 years, you could simply select sort order and switch from descending to ascending. Let's take a look at the next field in group by, which is team. Pretty self-explanatory. In this instance, we're going to see which team hit the most home runs total in the past 3 seasons. Also, notice that when we changed there, the sort by field reverted to what it was before we changed to player and event. So as we can see here, the Yankees hit a lot of home runs the past 3 years, leading the league with 814, followed by the Dodgers at 735. For our next field, we're going to get a little bit more specific here. We're going to search team and game date. Now, if we ran this query for every home run in the past 3 years, it would take a really, really long time. So we're going to narrow our search down a bit using the metric range field. So I want to see every home run just hit in 2019 with an exit velocity, let's say greater than 110. I'm going to start that query off. So we chose metric range, exit velocity. We set, we wanted everyone to be 110 or greater. We set the PA result to home run, and we removed 2017 and 2018, just looking at 2019. So it looks like the Phillies, Twins, and Astros all had one game where they hit 3 home runs over 110 miles per hour. What is this total thing over here? That's simply how many pitches were thrown by their opponent in that game. Now, if we go back to the example before where we used 2017, 2018, and 2019, and we go to venue and we remove the metric range, we can see where all of those home runs were hit over the past 3 years. So, okay, the Yankees hit the most home runs, and Oriole Park featured the most home runs hit, and I'm just going to pretend that Trey Mancini hit all 774 of them. League lets you see how many home runs the league hit overall the past 3 years, which is 18,466, and league and year is going to break down the query for you individually by year. So you're not going to see the lump sum of all 3 years. You're going to see how many were hit in 2019, 2017, and 2018. Now remember, we've just looked at group by through the lens of one particular query, but there are hundreds, if not thousands, of different searches you can do with these group bys. I mean, you now have the ability to run virtually any query you want. I mean, if you want to know how many swings and misses batters took in 0-0 counts in 2019 compared to 18, you can do that now. If you want to know which pitcher got burned on pitches on the edges, you can do that. If you want to know which venue allowed the most home runs in the colder months, the past 3 years, you can do that. I realize, okay, we've gone through a lot of stuff, especially in this second tutorial. There is one more thing in sort by. This is probably already a really, really, really long video, so I'm going to start with that next time so we can actually break that down a little bit more in depth. The next tutorial is also going to take a look at the change total pitch parameters as well as the graphs, and it's going to be out this upcoming Friday. I cannot stress this enough. I know I've done it a bunch during this video. Please feel free to send me or Savant Tips any question you may have on Twitter at Savant Tips, at AlexFast8, even if it's minuscule as double checking that you've run a query correctly. We're here to help you and start to mess around with the sort by. You know what I mean? You might as well, take a look ahead. If you have any questions, I'll probably get to them in the next video, but that is going to do it for tutorial number 2. I'm Alex Fast, and I'll see you guys on Friday. Stay safe and healthy.